Hi, in this final equation on equations of straight lines in point-slope form, we're going to take 3 points and we're going to try and find the area of that triangle, basically. So it's given us some guidance here and sort of kind of guide us how we might want to do it. Let's put the information on the question first. So we've got A is 3, 1. We've got B is 5, 7. And we've got C is 10, 2. And it says, by first using the equations of L1 and L2. Well, what are these equations? L1 is the equation of the line that passes through A and B. So the line that goes through A and B. Let's find this equation. This is going to be L1. And L2 passes through C and is perpendicular to L1. So L2 is going to basically pass through like this, isn't it? So that's a straight line. So that's L2, and it's perpendicular to the other line. And then once we've got those equations, somehow we're going to be able to find the area of the triangle ABC. So let's do that first. And I'm going to do this slightly quickly because we have done these kind of skills before. So the equation of L1, firstly, we need the gradient of L1. And to find the gradient, we can just do change in y over change in x using these 2 points. So the gradient is change in y over change in x. Now the change in y from here to here is, we're going from 1 to 7, which is a change of positive 6. And the change in x from 3 to 5, it's going up by 2. So the gradient of this is 3. So we've got the gradient's 3, and if we use a fixed point on this line, we've got a fixed point 3, 1, for example. So our fixed point is 3, 1. We could have used the other point. We could have also used the 5, 7. Then remember the equation of a straight line that goes through a fixed point x1, y1, and has gradient m. That equation was y minus y1 equals m brackets x minus x1. We explored that in previous videos. But actually, there's nothing stopping you just using y equals mx plus c here and just subbing in to find in the m and the c. So let's just use this. We've got y minus, wrong tool. Y minus y1, which was 1, equals m. Our gradient m was 3. X minus x1, the x1 was 3. So if we just expand out and simplify, y minus 1 is 3x minus 9. And so y is equal to 3x minus 8. Right, okay, brilliant. So we've got that. That's the equation of L1, y equals 3x minus 8. So y equals 3x minus 8. And we also want to find the equation of L2. Now, we know that L2 is perpendicular to L1. Now, if the gradient of L1 is 3, because that's the number from the x, then the gradient of L2, remember, is the perpendicular, is the negative reciprocal to get the perpendicular gradient. So the negative reciprocal of 3, well, the positive 3 becomes negative 3, and then we do the reciprocal, we do 1 over it, so it becomes negative 1 over 3. And again, we explore that in other videos. So the gradient of this is negative a third. And let's find the equation of this line that has gradient minus a third and goes through the point 10, 2. So let's put those points. So this is L2 now. It has a fixed point of, what was it? Sorry, it was 10, 2. My memory is terrible. And it has gradient equal to, it was minus a third, wasn't it? Yeah, minus a third. So let's just use this equation above again, the y minus y1 formula. Y minus y1 equals m brackets x minus x1. And let's just simplify a bit. I'm going to times everything by 3 because I don't like that fraction. So 3y minus 6 equals minus brackets x minus 10. I'll put minus 1 if I want. And then let's just expand out the bracket, get minus x plus 10. And then I could add 6. So 3y is equal to minus x plus 16. That will do for now. Now, I want to find the point of intersection of those 2 lines. And we'll see why I want to do that. But I want to find this point of intersection here. And to do that, I basically need to solve the equations for L1 and L2 simultaneously. So the equation for L1 was y equals 3x minus 8. And the equation for L2 was 3y equals minus x plus 16. Okay, Right, so let's solve that down here. So we got the 3y is equal to minus x plus 16, and the other equation was y equals 3x minus 8. And so we're finding the point of intersection. So to do that, what we could do is we could use substitution. So if we know that y is equal to 3x minus 8, I can substitute this 3x minus 8 into that y there, because we know that y is 3x minus 8. So if we do that, we get 3y is equal to minus x plus 16. Let's expand out the bracket. 9x minus 24 is minus x plus 16. So 10x is equal to 40, and so x is 4, that's nice. And then we can work out the y as well. So y is 3x minus 8, which we can see here. So we're going to get 3 times 4, which is 12, minus 8 is 4. Oh, so it's 4, 4. Lovely. So we've now got the point of intersection. This point of intersection here is just 4, 4. Now, why am I doing that? Remember, we want to find the area of the triangle ABC. So it's going to be, if I do it in red, ABC looks like this. Sorry, it's getting a bit messy. Let's see them in a bit. And if I highlight it, I want this triangle here. Now, to find the area of a triangle, I can do half times base times height, right? Now, we want base times perpendicular height. Now, if I use this as the base, then I could use that as the perpendicular height. Now, to find the length of this base, I need to find the distance between 3, 1 here and 5, 7 here. And to find the equation of this perpendicular height, I need the distance between 4, 4 and 10, 2. So let's just kind of like copy this information out below. So we've got 3, 1, 5, 7. There we go. And we've got this line here, perpendicular. So we've got 3, 1 here. I think it was 5, 7 at the top. Yeah, 5, 7 at the top. We got this point here is 4, 4. And then finally the point on the right was 10, 2. So I've got everything I need now. Now, as I said, I want to find the length of this line and the length of this line, so I can do half times base times height. Now, firstly, the length of the yellow line, so the base, we can use, do you remember the formula for the distance between 2 points? We can use the square root of the change in x squared plus the change in y squared. So for this yellow line, so we're doing it for the yellow line, the change in x is from 3 to 5. That's a change of 2. So we're going to do the square root of 2 squared plus, what's the change in y? From 1 to 7 is 6. So it's 6 squared. So that's going to be the square root of 4 plus 36, which is the square root of 40, which is the square root of 4 times the square root of 10, which is 2 root 10. So we've got that. I could just keep it as the square root of 40, to be honest. And then what about the perpendicular height? The perpendicular height, which is that the length of the purple line. We're going to use these 2 points this time. So it is the square root of the change in x. So from 4 to 10, it's a change in 6. So 6 squared. What's the change in y? From 4 to 2, it's a change of 2. It doesn't matter whether it's positive or negative, we're squaring it anyway. And that's going to be exactly the same. That's going to be root 40 again, or 2 root 10. So that means the area of this triangle, because remember we're just trying to find the area of this whole triangle ABC, is going to be half times base times height. So the area of ABC is going to be half times the base, which was root 40, times by the height, which was also root 40. Now, root 40 times root 40 is 40, so it's half times 40, which is 20 units squared. And I hope that is the final answer to this question, the area of that triangle.